Beneath the glittering surface of the tropical shallows, where sunlight splinters into shafts and the seabed rolls in soft ripples of sand, a faint, high-pitched clicking begins. At first it blends with the gentle swaying of seagrass and the distant croak of reef life. But then it sharpens, rapid, rhythmic scanning. It's not random. It's a code, a signal, a strategy unfolding. The pod moves as one, sleek, muscular silhouettes slicing through the blue in tight formation. These are bottlenose dolphins, Tursiops truncatus, though to call them by species alone is to ignore the role they play in this liquid battlefield. They are not passive wanderers of the sea. They are tacticians, they are hunters, and in these waters they are feared. With tails pulsing in perfect synchrony and flanks occasionally brushing in formation, the pod sweeps across a lagoon edge known to harbor dense schools of mullet. At the center swims an older female, scarred, experienced, flanked by her kin. Dolphins don't just live in groups, they operate within them, using relationships and hierarchies to coordinate actions. Matriarchs often lead the charge, combining decades of experience with social cohesion that can rival primate tribes. The clicks continue, echoes bouncing off fish, coral, sandbanks. This isn't sound for communication alone. This is echolocation deployed like sonar, each returning pulse revealing the size, distance, speed, even the direction of the prey. With this invisible vision, dolphins can hunt in waters clouded by silt or moonlight, but they don't act alone. One subgroup of the pod begins to arc wide, driving fish from the reef into open water. Another stays behind, lying in wait, perfectly still, like wolves crouched in the grass before the ambush. Then it happens. The flankers surge. Prey fish scatter in dense silver clouds, confused and penned in by coordinated dolphin movements. From below, one dolphin suddenly bursts upward, slamming the water with its tail, a behavior known as fish whacking. A single blow can stun or kill. In moments, the entire pod is in motion, some corralling the dazed fish, others taking turns to feed. There's no chaos, only calculation. This behavior isn't instinct alone, it's learned. Young dolphins observe and imitate, often practicing the same strike over and over until it becomes efficient. In some regions, pods have developed unique methods of hunting. In Florida Bay, dolphins use mud plumes to trap fish in a swirling vortex. In Shark Bay, Australia, certain individuals have learned to wear sea sponges on their rostrums to probe sandy bottoms for hidden prey, shielding themselves from sharp coral. This is not just hunting, it is innovation. Dolphins are not gentle when they don't need to be. When opportunity strikes, they exploit it with surprising aggression. Studies of stomach contents have shown that dolphins will occasionally hunt and consume cephalopods, smaller rays, even seabirds, when the chance presents itself. And when competing predators enter the scene, dolphins don't always retreat. In areas where food is scarce, conflict arises between dolphins and sharks. It's not unusual to find dolphins with deep scars from failed shark attacks, but just as often, sharks find themselves outmatched. A healthy adult dolphin is too fast, too agile, and, critically, not alone. Pods have been documented teaming up to defend against bull sharks, or even drive them away entirely. While a lone dolphin is vulnerable, a coordinated defense can turn the hunter into the hunted. Ramming at high speed with their hardened snouts, dolphins have been known to fatally wound sharks. One precise strike to the gills or underbelly can be enough. This level of cohesion is built on a foundation of complex social cognition. Dolphins understand roles. They use signature whistles, individual vocal markers akin to names, to keep track of each other. They form alliances, sometimes temporary, sometimes lasting decades. In the wild, males have been seen cooperating in duos or trios to gain access to females, while in other cases, entire superpods may temporarily merge, numbering in the hundreds, before dispersing again like smoke on the current. But their tactical prowess isn't limited to feeding or defense. Dolphins have also demonstrated a kind of spatial planning. In certain habitats, they exploit tidal movements to push fish into inescapable shallows. Others herd prey against walls or sandbanks, isolating them from escape. Timing, angle, and speed are all variables. The decision to strike isn't impulsive. It's often postponed until the odds are in their favor. Even their physiology reflects this precision. A dolphin's brain is among the largest relative to body size in the animal kingdom, second only to humans. The neocortex, the seat of higher-order thinking, is deeply folded and highly developed. The limbic system, responsible for emotion, is unusually complex. What this means in behavioral terms is not fully understood, but in practice, it grants them a memory for places, tactics, and possibly past interactions with both predators and prey. Despite their intelligence, dolphins remain bound to the harsh arithmetic of nature. Injuries, starvation, and predation still stalk them. Calves are particularly vulnerable. While the pod protects its young, rogue males can pose a threat during mating competition. Infanticide, though rare, has been documented, removing offspring that are not theirs to bring a female back into estrus. The sea is not sentimental. Strategy is not always noble. And yet, even in this environment, dolphins show signs of curiosity and learning far beyond what's necessary for survival. They approach boats, interact with unfamiliar objects, even engage in what some researchers interpret as play. Whether this behavior stems from boredom, intelligence, or a form of social bonding is debated, but the fact remains. Their actions are often self-driven, rather than purely reactive. As the hunt ends and the pod slows, some individuals begin to breach, arcing through the surface in bursts of speed and spray. It may serve as a display of dominance or a signal to regroup. It could be sheer exhilaration, a physiological response to a successful strike. But whatever the cause, it's a moment of unity. Dozens of sleek bodies slicing skyward in rhythmic succession, their clicks and whistles echoing through the reef like an underwater code. Dolphins are not the innocent mascots of the sea. They are strategic, social predators, wired for cooperation, sculpted by selection, and sharpened by experience. In the hierarchy of marine hunters, they are unique not for their power, but for their planning. The ocean, vast and hostile, favors those who can think ahead. And in this game of survival, dolphins are not just players. They are tacticians. They are sonic wolves. Far below the rolling rhythm of the waves, where sunlight loses its grip and the ocean begins to darken into blue twilight, an immense body moves in silence. Its shadow distorts the contours of the sea, passing over slopes of sediment and slow-drifting clouds of plankton. At first, there is only calm, a deceptive stillness that masks the presence of one of the largest predators on Earth. Then from the depths comes a sound, low, vast, and drawn from somewhere ancient. A pulsing series of clicks, measured, deliberate, fanning through the water like seismic waves. A signal, not for us, but for something alive and aware, still unseen in the blackness below. This is the language of the deep, the voice of a whale. To understand the true dominance of whales in the marine world, it is necessary to shed the image of passive giants. These are not merely floating relics of a bygone era. From the streamlined speed of the orca to the abyssal dives of the sperm whale, they represent a spectrum of evolutionary precision, adapted not just to survive the sea, but to master it. Near the edge of an Arctic floe, just beyond the reach of surface ice, a group of orcas gathers. Their dorsal fins breach the water with machine-like regularity, tall and sharp. Beneath the surface, they are not resting. They are scouting. The ice shelf hides something they've come for. Seals resting on the undersides or clinging to smaller floes. But the orcas don't charge blindly. They recon the edge first, adjusting formation like units in a playbook rehearsed over generations. A few circle far below the ice, using echolocation not only to map the terrain, but to sense minute vibrations above. Sound travels faster and farther through salt water than air, and these animals use it like a scalpel, identifying prey hidden behind walls of frozen silence. When they strike, it isn't random. With coordinated force, several orcas generate a wave that lifts and fractures the ice floe from beneath, sending a startled seal skidding into the open water. Another orca surges up from the dark, jaws closing before the seal can orient itself. The kill is quick, efficient, shared among the pod. This is a technique, taught, refined, and passed down. Orcas, or Sinus orca, belong to a rare subset of animals that exhibit cultural behavior, patterns of learning and transmission that differ by region and pod. Some use waves. Others strand themselves temporarily on beaches to snatch seals before wriggling back to sea. A few specialize in hunting sharks, flipping them upside down into a state of tonic immobility before disemboweling them. Their diet is not determined by biology alone, but by tradition, taught by mothers, perfected by siblings, repeated with startling success. Even among whales that do not hunt with such aggression, power takes other forms. In the tropics, a blue whale exhales at the surface, the mist from its blowhole rising over 30 feet before fading into the warm air. At nearly 100 feet long and weighing more than 150 tons, it is the largest animal ever to have lived. And yet, it feeds on some of the smallest. Its mouth, capable of engulfing 90,000 liters of water in a single lunge, closes over clouds of krill, straining them through baleen plates in a quiet act of consumption. But quiet does not mean weak. A blue whale's heart is the size of a small car. Its tongue outweighs a full-grown elephant. Its low-frequency calls can travel thousands of kilometers across entire ocean basins, forming a kind of acoustic map that few creatures can even hear. These sounds, known as infrasonics, are not used to stun prey like echolocation, but to communicate, possibly to navigate, and perhaps even to connect with others across vast distances. We do not yet fully understand how blue whales use this deep thunder, but the prevailing theories suggest a mix of orientation, social contact, and mating. In an environment where vision fades within meters, sound is king. And for whales, the ocean is a resonating chamber. In contrast, toothed whales, like the sperm whale, have taken echolocation to its most extreme form. In the dark bathypelagic zone, where sunlight is a rumor and pressure would crush a human like paper, the sperm whale descends. Its massive block-shaped head, housing the largest brain on Earth, contains an organ called the spermaceti, which plays a key role in echolocation. The whale emits rapid clicks, each one sharper and louder than a gunshot. These pulses travel through water and bounce off squid, fish, or rock, returning as a ghostly echo. With this feedback, the whale constructs an image of its surroundings in pitch blackness, and what it hunts is no easy prey. In the deep trenches of the world's oceans, giant squid drift like shadows. Some reach lengths of 40 feet, their tentacles lined with hooks and suctioned pads. When a sperm whale catches one, the struggle may last minutes. It is a fight of soft tissue and precision versus muscle and sonar. Scars etched into the heads of sperm whales, long sucker-ringed trails, are the evidence left behind from these deep duels. Power in the world of whales takes many shapes. Sometimes it is physical, like the downward plunge of a tail fluke that propels an orca toward a school of herring. In other cases, it's chemical, like the release of ambergris, a digestive secretion from sperm whales that floats for months and may serve functions we still don't fully understand, and at times it is social. Female whales form long-term bonds, especially in orcas and pilot whales. They share food, raise calves cooperatively, and respond to distress calls across miles of water. That social connection is both their strength and, in some cases, their vulnerability. Strandings, events where entire pods beach themselves, may stem from a failure of navigation or sonar disorientation in shallow coastal terrain. But often, they happen because the group refuses to abandon a sick or confused member. Loyalty may override survival. What grants cohesion can also carry cost. The mystery deepens in species like the narwhal and beaked whale, whose behaviors are so elusive that entire aspects of their lives remain undocumented. Some dive deeper than any other mammal, over 9,000 feet in some cases, staying submerged for nearly 2 hours. Others produce sounds outside the range of our detection or live in remote, ice-locked regions beyond regular human observation. Still, one truth binds them all. In every ocean, whales dominate the acoustic domain. They navigate through corridors of sound, hunt with clicks sharp enough to chart the heartbeats of fish, and send infrasonic messages across planetary scales. Their size grants them presence, but it is sound that gives them influence. They are not merely the largest animals in the sea. They are the most sonically powerful, the most culturally rich, and in many cases the most precise. As the sunlight fades and the horizon shifts to night, the surface calms again. A pair of humpbacks rise in slow arcs, exhaling with thunderous blows before descending back into the gloom. Below them, the sea is far from silent. It pulses with energy, echoing through bones and sediment, reef and trench. And somewhere in that endless black, a call travels unbroken, measured, vast and full of meaning no human can yet decode. Here in the deep thunder, the giants do not speak, they command. In the warm, grainy darkness of a moonlit beach, where the land ends in a gentle slope of sand, something ancient stirs. The air is still, punctuated only by the sound of distant waves folding onto the shore in rhythm, like slow, patient breathing. From beneath the sand, a flurry of motion breaks the silence. Dozens of tiny hatchlings erupt from the earth in sudden unison, their flippers thrashing against loose grains as instinct compels them toward a horizon they have never seen. For these newborn sea turtles, the ocean is not a home, it is a gauntlet. The beach crawl is their first test, and one few will survive. Ghost crabs skitter sideways under the moonlight, sharp-eyed and quick, grabbing at the vulnerable with crushing claws. Birds sweep low from the dunes. The turtles, no larger than a human palm, have no defense but urgency and camouflage. Their shells, not yet hardened, are thin and pliable, a shield in the making, not yet ready. The lucky few that reach the surf are immediately taken by another force, the sea. Waves toss them without mercy, flipping and tumbling them through foam and current. And still they paddle, driven not by thought but by evolutionary programming older than recorded time. This is how it begins for a sea turtle, a life of odds, a life of endurance. As the hatchlings disappear into the pelagic zone, the open sea swallows them into its vast anonymity. For years they will drift among ocean currents, riding mats of sargassum or kelp, feeding on plankton, jellyfish and small crustaceans. This stage, often called the lost years, remains largely hidden from science. Tracking technology struggles to follow creatures so small and elusive, and most juveniles vanish into statistical silence. Only a fraction of a percent will make it to adulthood. But for those that do, survival shifts from evasion to durability. An adult sea turtle becomes something else entirely. An armored cruiser, slow but purposeful, built not for aggression but for resilience. Its shell, a fusion of ribs and spine covered in keratin, is not merely a shield, it is an evolutionary triumph. Capable of withstanding bites from reef sharks and even tiger sharks, it turns the turtle into one of the few marine animals that can afford to ignore its predators. The green sea turtle, for instance, glides through shallow reefs with the casual confidence of a creature that has earned its place. With a powerful front flipper stroke and a gentle rock of the hips, it moves like a submarine powered by silent turbines. Its beak, serrated like garden shears, is adapted for cropping seagrass and algae. In some ecosystems, these grazing habits help maintain the balance of seagrass meadows, preventing overgrowth and allowing diverse marine life to flourish. In that sense, the turtle is not just a survivor, it is a gardener of the sea. But not all turtles are herbivores. The loggerhead turtle, stocky and broad-headed, feeds on hard-shelled prey like whelks and conchs, its massive jaw muscles capable of crushing thick exoskeletons. Leatherbacks, the largest of all sea turtles, are specialized jellyfish hunters, consuming vast numbers of gelatinous plankton. Their esophagi are lined with backward-facing spines to trap slippery prey, allowing them to feed efficiently even in nutrient-poor waters. It's an unusual dietary niche, but it reduces competition with other large marine species. What sets turtles apart, more than their physical adaptations, is their long-game approach to survival. Where most sea creatures live fast and reproduce early, turtles take decades to mature. A female green turtle, for instance, may not nest until she is 25 or 30 years old. But when she does, she returns not just to any beach, but to the very one where she was born. Using Earth's magnetic fields as a navigational map encoded in their neural architecture, sea turtles cross entire oceans to find a speck of sand they haven't seen in decades. This natal homing behavior is among the most precise and mysterious in the animal kingdom. Satellite tracking has shown green turtles crossing the Atlantic from Brazil to West Africa without veering off course by more than a few degrees. Along the way, they avoid long-line fisheries, dodge marine debris, and steer clear of areas with known predators. It's not just endurance. It's memory, sensory acuity, and navigational skill embedded in instinct. Yet the open ocean is no sanctuary. Adult turtles still face threats, both natural and unnatural. Tiger sharks are one of the few predators capable of breaching a turtle's shell, focusing their bites on the flippers or exposed areas around the neck and tail. Killer whales in some regions have been observed flipping turtles upside down, immobilizing them before striking. But more often it is human activity that does the damage. Plastic bags mistaken for jellyfish, fishing nets that entangle flippers, light pollution disorienting hatchlings, coastal development erasing nesting grounds. Even so, sea turtles have survived worse. Their lineage stretches back over 100 million years, outlasting the mass extinction that ended the age of dinosaurs, surviving ice ages, sea level changes, and climatic upheaval that rewrote the biology of the planet. They have persisted not through strength or speed, but by being perfectly designed for a niche that rarely rewards haste. Their shell, once an awkward evolutionary experiment, became a passport through time. Not armor alone, but a self-contained fortress, a pressure buffer, a buoyancy regulator, a deterrent, and an emblem of an animal that has refused to vanish. Beneath the swell of a warm Pacific reef, a female turtle surfaces. Her nostrils break the water for only seconds before she dives again, her body moving with slow, deliberate grace. Her path is not erratic. She knows this route. In a few months, she will return to land to nest again. She will crawl slowly across sand that scorches her plastron, dig a cavity with her hind flippers, and deposit over 100 eggs into the same terrain where her life began. Then she will leave without looking back. For her, survival is not about watching the past. It's about ensuring its return. Every egg is a statistical miracle waiting to prove the odds wrong, and some will. In the realm of the fast and the furious, the sea turtle stands as an icon of patience. Armored, unhurried, and nearly unchanged across epochs, it is not built to conquer, but to endure. And in a world where so many species flash and vanish, endurance is its own kind of power. The turtle remains, shell intact, moving forward, one slow stroke at a time. In the muted half-light of the ocean's upper layers, where beams of sunlight ripple and fracture through swells, the reef below seems distant, as if viewed through a window that distorts time. Here, in the suspended calm between surface and seafloor, movement takes on a different character. There are no frantic chases, no lunges, no bursts of teeth. Instead, there is glide, grace, precision. A vast shape emerges from the haze, framed in soft blues and flickering gold. Its wingspan stretches wider than a man is tall, casting a slow-moving shadow on the coral beneath. The animal does not flap. It doesn't need to. With each steady undulation of its pectoral fins, broad and tapered like the wings of a bird, it floats forward, seemingly unaffected by gravity or current. This is a reef manta, Mobula alfredi, and though its flight appears casual, every movement is deliberate. To witness a manta ray from below is to misunderstand it. From that angle it seems ethereal, barely tethered to the physical world, its underside pale, even luminous, like a living reflection of the sky. But approach from the side or above, and its features become clear. The cephalic fins, coiled like horns beside its mouth, unfurl with slow intent. They guide water and plankton into its gaping, filter-feeding maw, where comb-like gill rakers trap the microscopic life that fuels this leviathan. Despite its size, manta rays can exceed 20 feet across and weigh over a ton. It feeds not with jaws or claws, but with volume. Like whales and basking sharks, mantas are passive filter feeders. They swim with mouths agape, sometimes in slow figure eights over rich upwellings, sometimes in spiraling formations with other rays, as if orchestrating an invisible ballet of ingestion. They feed where the water pulses with plankton, often near seamounts, cleaning stations, or channels that funnel nutrient-rich currents. Yet the manta is more than just a plankton vacuum. It is a sentinel of its ecosystem, a highly mobile, highly aware participant in the rhythm of tropical seas. Unlike many of the reef's larger inhabitants, mantas are not ambush predators or brute enforcers. They rely on their sensitivity to survive. Their brains, in proportion to body size, are the largest of any fish, larger even than those of some birds and reptiles. The areas responsible for learning, memory, and problem-solving are unusually developed, suggesting a cognitive map more intricate than once believed. This intelligence is not hypothetical. In cleaning stations, specific spots on the reef where small wrasses and cleaner fish pick parasites from larger animals, mantas wait their turn. They approach slowly, hover over the site, and allow cleaner species to comb through their gills, mouths, and undersides. This isn't passive, it's learned behavior. Mantas have been observed circling these stations, returning at regular intervals, even queuing behind others in what seems like a display of spatial awareness and memory. Some individuals return to the same locations over years, navigating hundreds of kilometers to reach familiar reef outposts. But even with their size and speed, manta rays are not immune to threat. Sharks, particularly large tiger sharks, have been known to pursue and injure them. A single deep bite to the wing can alter a manta's mobility for life, and many rays carry scars as silent testimony to past escapes. When threatened, mantas don't fight. They flee, rapidly accelerating in powerful bursts, twisting their bodies to break visual lock, diving deeper, or veering into currents that work in their favor. Their speed is surprising, and their turns, tight, banked, and sudden, can outmaneuver most predators in open water. In shallower zones, they exploit topography. Gliding just above coral heads or over steep drop-offs, they can disappear from a shark's line of sight in seconds. And while they lack venom or armor, their sheer awareness often protects them. Their eyes, positioned on the sides of the head, give them a nearly panoramic view of the world around them. Combined with sensitive electroreceptors along their cephalic lobes, mantas maintain a constant readout of nearby movement, water pressure, and bioelectric signals, a sixth sense that functions as a predator early warning system. Surprisingly, despite their brainpower and grace, mantas breed slowly. Females give birth to a single pup after a gestation that can last over a year. The young are born fully formed, rolled like soft sushi, and released into the open sea to fend for themselves. Maturity may take up to 10 years, and reproduction is infrequent. This makes them particularly vulnerable to overfishing and habitat degradation. Their gill plates, prized in some cultures for traditional medicine, have fueled a market that pushes them further toward decline, even though scientific studies have found no measurable health benefits from such consumption. In their natural environment, however, mantas serve no destructive purpose. They don't decimate fish stocks or destabilize food chains. They are moderators, linkers of systems. By consuming plankton, they help regulate blooms that could otherwise upset reef balance. By frequenting cleaning stations, they support entire communities of reef fish. And by migrating along ancient routes, they connect ecosystems that might otherwise remain biologically isolated. There is perhaps something unquantifiable about the manta ray's presence in the sea. Divers speak of encounters as if recalling dream fragments, silent gliders approaching with curiosity, spiraling overhead like underwater aircraft, then vanishing into haze. Mantas often approach human swimmers, not with aggression or fear, but with what appears to be curiosity. They circle, pause, and observe. Whether this behavior reflects intelligence or simple habituation is debated, but few other fish exhibit such non-reactive, deliberate engagement. Above a submerged reef shelf in the Maldives, a dozen mantas spiral in synchrony, mouths wide, cephalic fins steering invisible torrents of plankton toward their gills. The movement is not chaotic. It is choreographed, each ray maintaining perfect distance from the next, responding to subtle eddies and swirls, navigating a banquet that would be invisible to us. Their shadows flicker on the reef floor, a slow-moving constellation of intention and hunger. And then, as if cued by some unspoken signal, they rise. Together they ascend from the reef, wings lifting with perfect symmetry, and vanish into the open blue. Not with haste, but with purpose. Manta rays are not hunters, and yet they command the water. They do not roar, but they are heard by those who watch closely enough to understand the silent movements of giants. They are architects of motion, symbols of connection, and survivors of an ocean that values more than just power. In a world of teeth and speed, the manta ray remains something else entirely, a winged shadow, gliding where few can follow, feeding in the sky of the sea. The coral reef at first glance is a spectacle of motion and color. Schools of antheas flicker like confetti above staghorn coral, parrotfish rasp algae from limestone, and butterflyfish weave through anemones in a quiet parade. But the beauty is misleading. Beneath the surface of this marine metropolis, beneath its swarming life and false tranquility, is an entire world governed by shadows, by the cracks between coral heads, by the tunnels in limestone, and by the cold, narrow layers that never see light. These are the territories of the moray eel. From the outside, a moray's den is barely distinguishable. Just another shadow under a ledge, a narrow slit between sponges, a recess half buried in sand. But inside, coiled and motionless, lies one of the reef's most precise ambush predators. The body is long, muscular, and sinuous, more like a stretched muscle than a fish, coated in a mucus-rich skin that glistens in the dim light, lacking scales and often patterned in mottled camouflage. Its eyes remain still, the jaws parted slightly, revealing needle-thin teeth that glint even without movement. This open-mouthed posture isn't a threat, it's a necessity. Moray eels breathe by actively pumping water over their gills, and the rhythmic motion of their gaping jaw is part of their ventilation system. But it also serves another purpose. It makes them look ready to strike, always. Morays do not chase, they wait. Patience is their first weapon. Nestled in their crevice, they become part of the reef architecture, undetectable to most prey until it's far too late. When a fish, crustacean or octopus ventures too close, the strike is instantaneous. Faster than a blink, the eel lunges from its hole with a speed that betrays its otherwise languid movements. But what makes the attack so lethal is not the bite itself, it's what happens next. Unlike most fish, moray eels possess two sets of jaws. The first, as expected, bites down and holds. But it is the second, pharyngeal jaws that deliver the killing blow. These secondary jaws, housed in the throat, shoot forward into the mouth cavity, latch onto the prey, and pull it backward into the esophagus. It's a mechanism seen nowhere else among vertebrates, resembling something more at home in an alien biology manual than a reef ecology guide. This adaptation allows morays to feed effectively within confined spaces, where suction feeding is impractical. A struggling fish cannot escape once both sets of jaws are engaged. The prey is dragged inward, resisting until the reef swallows it whole. Most species of moray rely on this method of ambush to hunt alone, but in certain parts of the Indo-Pacific, something more remarkable unfolds. In the coral labyrinths off Egypt or the Maldives, groupers, large, solitary reef predators, have been observed approaching moray eels and engaging in what appears to be cooperative hunting. The grouper will perform a strange, repeated headshake in front of the eel's crevice, as if signaling. The moray emerges, and the two move off together into the reef. The grouper searches the open spaces. The moray slithers into crevices, flushing out fish that hide between rocks. Prey that escapes the eel finds itself in the grouper's mouth. Those that try to hide from the grouper are extracted by the eel. It is not an accident, it is synergy. This kind of interspecies hunting alliance is rare in the animal kingdom and even rarer among fish. It suggests a level of behavioral complexity and mutual benefit that defies the stereotype of mindless reef predation. The moray is no simple killer. It is a partner in strategy, exploiting its shape and stealth in exchange for a share of the spoils. Still, life for a moray is not without danger. Despite their formidable bite and reclusive habits, moray eels are vulnerable to sharks, barracudas, and larger reef predators. Their long bodies, when exposed, can be torn apart by a single well-timed strike, but that's precisely why they rarely expose themselves. A moray that is forced into the open swims with an undulating S motion, powerful but awkward in open water. Its true domain is the confined space. When danger approaches, a wise moray backs into its lair, leaving only its head visible, the jaws slowly opening and closing in a show of warning. Not all morays are created equal. Some, like the giant moray, Gymnothorax javanicus, can grow over 10 feet long and possess the jaw power to crush bone. Others, such as the snowflake moray, specialize in crustaceans, using molar-like teeth to crack open shells. Many exhibit cryptic coloration, browns, greens, and speckles, while a few, like the ribbon eel, transition in color and even sex as they age, starting life as males and transforming into females later in life. This sequential hermaphroditism adds another layer of complexity to an animal already brimming with evolutionary quirks. The skin of the moray is another defensive trait. Thick, mucus-coated, and sometimes toxic, it protects against abrasion in narrow spaces and may deter parasites and attackers. Without scales to armor them, morays rely on this slick, secreted layer as a kind of biological armor, both flexible and resistant to infection. This, coupled with the ability to contort their bodies into impossibly tight spaces, allows them to inhabit territories that no other large predator can access. Though they are often vilified in folklore and feared by divers, sometimes for good reason, moray eels are not naturally aggressive to humans. Most bites occur when people attempt to feed them or place their hands too close to occupied crevices. The eel's poor vision and rapid strike response means mistakes happen, but in their world, mistakes are rare. Their senses are tuned to vibration and chemical cues. A flicker in the current, a cloud of disturbed sand, the scent of blood in the water. Each is a message, a signal that prey is near, or that a predator approaches. As the light fades from the reef and shadows stretch long, the daytime schools begin to settle. Wrasses find crevices to wedge into, parrotfish cocoon themselves in mucus for the night, and the reef dims into nocturnal rhythm. But this is when the moray begins to stir. The shift from daytime camouflage to nighttime patrol is subtle. It does not emerge fully, not right away. First, the head scans the current, reading it. Then, with slow, deliberate motion, the body uncoils and glides from its cave. It does not go far. A few feet, perhaps, enough to inspect the terrain, to find a better hole, to begin the watch once again. In a habitat where speed often defines success, the moray eel thrives on patience. It is not designed for chase or pursuit. It does not waste energy. It waits, coiled and silent, until opportunity presents itself. Then it acts with speed and precision unmatched by any fish its size. In the shadows of the reef, power belongs not to the loudest or the fastest, but to those who master stillness. Here in the cracks of coral, in the tunnels no predator dares enter, the moray holds court. Not by dominating the reef with force, but by disappearing into its very structure, by becoming the reef's shadow, its ambush, and its silent strike. In the shallows of a quiet reef slope, where the tide breathes against the coral in steady pulses, and the sand shifts gently with every surge, a curious patch of seagrass seems to move without wind. No predator has struck, no fish has darted past, yet something is different, too fluid, too synchronized to be random. Then as the silt settles and the false leaves drift apart, the illusion unravels. What seemed like part of the scenery liquefies into motion, arms unfurling with eerie control, skin morphing from textured green to smooth beige in an instant. It's not a plant, it's not even a fish. It's an octopus, Octopus vulgaris, the common octopus, though there's nothing common about what it just did. The octopus is unlike anything else on the reef. Boneless, fluid-bodied, and covered in chromatophores, cells capable of expanding and contracting to reflect light and pigment, it is a living canvas. With a single thought, it changes not only color, but texture and pattern. It can mimic rocks, coral, algae, even other marine creatures. But camouflage isn't its only trick. It's just the opening move in a long list of tactical advantages. As the octopus drifts along the seafloor, its 8 arms sweep outward, moving independently yet harmoniously, each lined with rows of suction cups that serve as both tactile sensors and grasping tools. It explores everything it passes, probing crevices, feeling surfaces, tasting the water through chemoreceptors embedded in its skin. It doesn't rely on speed or brute strength. Instead, it collects information constantly, adapting to new data within seconds. Few animals possess such distributed awareness. Its nervous system is decentralized, with over 2/3 of its neurons located in the arms themselves. Each limb is capable of independent decision-making, giving the octopus a body that can literally think with its arms. This decentralized intelligence allows for stunning feats of manipulation. In experiments, octopuses have opened jars, solved mazes, and escaped from locked enclosures. In the wild, they've been seen gathering coconut shells, arranging rocks, and constructing temporary shelters, behaviors that edge close to tool use. It is one of the only invertebrates known to do so. In Indonesian waters, the veined octopus has been filmed stacking discarded clamshells and using them as armor, crawling across the sea floor with its shelter tucked beneath like a hermit crab wearing a helmet. But even with all this mental and physical adaptability, the octopus is still a predator, a lethal one. It doesn't hunt with loud bursts or extended chases. It stalks. Its approach is low and deliberate, hugging the contours of the reef, skin shifting to match the seascape in real time. When it identifies a crab or shrimp nestled between rocks, it positions its body just outside of view, then extends 1 or 2 arms with surgical precision. The movement is slow, measured in millimeters per second. The arm slides along the coral, snakes into the crevice, and then snaps shut with hundreds of suction cups locking onto the shell of its prey. If resistance follows, the octopus injects venom through its beak, a sharp, parrot-like mouth concealed at the center of its arms. The venom paralyzes, sometimes liquefies. A crab's struggle ends in seconds. What remains is dragged beneath a rock, dismantled in silence. Some species take this chemical warfare to another level. The blue-ringed octopus, found in tide pools and coral rubble across the Pacific, is no larger than a golf ball, but carries venom potent enough to kill a human. Its toxin, tetrodotoxin, shuts down nerve function within minutes. There is no cure. What makes this predator more alarming is that it gives almost no warning. Only when threatened do its iridescent rings flare into view, a signal not of threat, but of certainty. It doesn't bluff. Despite its arsenal, the octopus is not invincible. Its soft body is easy prey if caught, and its lifespan is brutally short. Most species live only a year or 2. Some giants, like the Pacific octopus, may reach 5 or 6, but even that ends with programmed senescence, cellular self-destruction once reproduction is complete. Mating is brief, often fatal. The male deposits a sperm packet using a specialized arm and retreats if he can. The female lays thousands of eggs, then guards them obsessively, often refusing food. She dies soon after the hatchlings disperse. Yet within that limited span, the octopus achieves a lifetime's worth of strategy. Its behavioral plasticity, ability to learn from experience, and capacity to innovate in unpredictable ways has made it a subject of intense study. Unlike fish, which rely largely on instinct, octopuses seem to engage in something more improvisational. Their problem-solving isn't rigid, it's responsive. Their intelligence doesn't fit the mold of vertebrate cognition, and that may be the most alien aspect of all. One of the most mysterious behaviors is its display of mimicry. The mimic octopus, Thormoctopus mimicus, found in Southeast Asia, takes disguise to theatrical extremes. It doesn't just blend in, it performs. It contorts its limbs and body to impersonate lionfish, sea snakes, flatfish, whichever animal would deter its current predator. In one encounter, a single mimic octopus was observed adopting several personas in succession, choosing which to mimic based on the specific threat it faced. This is not just camouflage, it's deception, intentional, context-specific and rehearsed. As the sun begins to lower and the reef falls under the spell of dusk, the octopus becomes more active. Twilight is its window. The light is dim enough to move freely, but not yet dark enough for the large nocturnal predators to emerge in full. The reef begins to change. Colors dim, shadows stretch, fish retreat to their burrows. The octopus, by contrast, seems energized. It leaves its den and glides over the coral heads, arms trailing behind like streamers in current. It's not hurried, but it is decisive. It has mapped this ground before. When it finally settles again, perhaps in the hollow of a rock or beneath a sponge, it does so with care. It arranges shells and debris at the entrance, a makeshift barricade. Then, without a sound, it melts into its surroundings. The skin ripples, roughens, changes hue. Its eye narrows, the pupil adjusting like an aperture, scanning for contrast and shape. By the time it is still, nothing about the rock appears out of place. It has vanished. The reef continues around it, crabs scuttling, damselfish hovering, currents whispering against stone, and the octopus watches. It is not asleep. It is never far from action. Because the moment prey wanders close or a threat dares to intrude, it will move again, not with noise or panic, but with the precision of a creature that has never relied on muscle alone. In a sea ruled by speed, strength, and scale, the octopus survives through intelligence, deception, and stealth. It is not armored. It does not overpower. It adapts. And in that constant reinvention, through shape, skin, and strategy, it remains the ocean's ultimate shapeshifter. A silent hunter sculpted not by power, but by possibility. At the edge of the Arctic Circle, where the land breaks into splintered ice and the sea exhales through shifting leads, the environment is fluid, deceptive, and unforgiving. The horizon is neither truly ocean nor land, but a volatile space between, constantly redrawn by tides, storms, and temperature. This is not a place for hesitation. For the creatures that live here, survival means knowing how to move in both worlds, and knowing when to leave one behind. From a jagged ice shelf scattered with wind-blown snow, a seal watches the water. The light is harsh and indirect, bouncing off ice in every direction, and the air carries the dry chill of a world shaped by pressure and scarcity. The seal, a bearded adult male weighing over 300 kilograms, appears relaxed, head up, nostrils flaring rhythmically. But its stillness is strategic. In this landscape, motion invites death. Below the ice, the water is black and near silent, save for the groaning of frozen plates shifting above. Here, seals are not the hunters. They are hunted. Killer whales prowl the perimeter, their echolocation sweeping the under-ice realm like sonar from a submerged fleet. These apex predators work in pods, communicating in clicks and pulsed calls, coordinating position, waiting for the right moment to strike. A solitary seal venturing too far from a breathing hole risks being encircled and ambushed from below. When orcas find prey on the ice, they don't hesitate to create their own opportunity. Several have been observed launching coordinated waves to fracture flows and knock seals into the sea, where escape is nearly impossible. In such waters, the line between intelligence and teamwork becomes the only defense against speed and force. But the seal is not defenseless. While ungainly on land, it becomes something else in the water. An agile, sleek-bodied swimmer capable of sharp turns and bursts of surprising acceleration. Its body is torpedo-shaped, insulated by thick blubber and powered by hind flippers that scull in alternating strokes. The front flippers, small and clawed, act as rudders and paddles when needed, but are most effective for navigation in tight under-ice spaces. Using stored oxygen in its blood and muscles, a seal can stay submerged for over 20 minutes, traveling hundreds of meters between holes without surfacing. Some species, like the Weddell seal of Antarctica, take this further. They use their teeth to grind breathing holes in thick sea ice, maintaining access to air throughout the long polar winter. Their incisors are flattened and worn from this repetitive action, an evolutionary compromise between feeding and surviving in a frozen world. Others, like the harbor seal, remain coastal and opportunistic, using rocky shores and estuaries as refuges from the deep water threats of great whites and transient orcas. But life above the surface brings its own hazards. In the high Arctic, polar bears patrol the ice edge with calculated persistence. Unlike the speed-based tactics of marine hunters, polar bears rely on stealth, patience, and acute olfactory senses. A bear may wait motionless beside a breathing hole for hours, ears flattened, nose twitching, until the sound of rising bubbles signals an approaching seal. A misstep, surfacing too early, hesitating at the hole, ends in a clawed paw descending with brutal force. The seal's thick fur and blubber offer no real protection from a strike designed to crush and drag. To reduce exposure, some seals adapt with mobility and grouping. Elephant seals, especially the northern variety, haul out in enormous colonies numbering in the thousands. On beaches from California to Baja, they form hierarchies, with dominant males battling for breeding rights while subordinates crowd the periphery. The young, still learning the peril of open water, form pods and shadow adult females during foraging dives. This temporary collective behavior doesn't offer much in the way of true cooperation, but it creates visual confusion for predators, especially those hunting from below. Sharks struggle to single out individuals among a tight, shifting group, and the time delay in selecting a target can be enough for most to escape. Intelligence plays a significant role, particularly in species like the California sea lion. These pinnipeds navigate the complex geography of coastal cliffs and kelp forests, using visual landmarks to orient themselves and echolocation-like hearing to detect underwater echoes. Trained individuals have shown cognitive flexibility on par with dolphins in controlled settings, solving puzzles, remembering symbols, and even cooperating with humans in military detection programs. In the wild, they use their brains not just for foraging, but for risk assessment. Sea lions often adjust their dive depth, timing, and foraging routes in response to shifting predator activity, and they communicate through barks and clicks, especially during group movements and territorial disputes. What makes seals particularly effective survivors in this in-between world is their adaptability across terrain types. On land, they can rest, breed, and escape some marine threats, but must contend with heat, dehydration, and land-based predators. In the water, they gain access to rich feeding grounds and fast travel, but at the constant cost of vulnerability. Their life is a continuous oscillation between risk types, and their physiology reflects that balance. A streamlined form for swimming, thick fur or blubber for insulation, muscular forelimbs for dragging across rocks, and lungs capable of collapsing under pressure to prevent nitrogen absorption, all are compromises forged by evolution in a landscape of shifting rules. Even their vocalizations reflect a need for versatility. Male leopard seals, solitary and territorial, sing complex underwater songs during mating season, modulating tone, pitch, and rhythm in a display more often associated with whales than carnivorous pinnipeds. These haunting calls travel through Antarctic waters, advertising strength and warding off rivals without the need for combat. In contrast, the cacophony of a fur seal rookery, constant yelps, barks, and wails, creates a sonic wall that masks individual calls, forcing mothers to develop signature vocalizations that their pups can identify even in a sea of noise. Beneath the raw athleticism and primal stakes, there is a quieter layer of strategy. Seals learn. Some individuals have been documented altering their haul-out schedules based on tide patterns, while others shift their migration routes in response to fishing activity. Their presence at the intersection of land and sea exposes them to both natural and human threats: bycatch, entanglement, pollution, habitat loss. But it also gives them flexibility few other predators possess. They are neither bound to the shore nor enslaved to the ocean. They are travelers between states. As dusk settles over the coast and the water reflects the first glimmer of stars, a group of harbor seals drifts just offshore. Their eyes remain open, scanning the darkening surface. One by one they dive, not with urgency but with purpose. Below, the kelp forest sways gently in the current, its long fronds muffling sound and shadowing movement. The seals slip between them with practiced ease, disappearing into the green gloom like shadows that have chosen to move on. Seals are not the rulers of either domain. They are not the fastest in water, nor the strongest on land, but they are the most capable of living in both, of reading the language of surf and ice, claw and tooth. They are the bridge between two worlds in conflict, the survivors not of strength alone, but of strategy and place. In the war between land and sea, they do not pick a side. They raid both. Far from shore, where the ocean loses all memory of land and begins to resemble a vast, shifting desert of blue, there are no hiding places. No reef walls to dart behind, no shadows of mangroves, no ice shelves to cling to. Just water, layered in temperatures and divided by invisible currents, stretching into a horizon that seems to go nowhere. Here, life follows a stricter rhythm, one dictated not by coral tides or tidal pools, but by the sheer, uninterrupted openness of the sea. And at the top of this unbounded domain, patrolling its layers with purpose and precision, is the shark. Sharks are not one thing. They are a category, an entire evolutionary guild of marine predators honed by over 400 million years of refinement. They do not rely on brute force alone, nor do they adhere to a single model of hunting. From the shallow fringing reef to the lightless trenches of the abyss, different species apply different strategies to dominate their slice of the ocean. What unites them is not their shape or size, but their mastery of the kill, each adapted to a different theater of war. In the tropical shallows of a barrier reef, a blacktip reef shark carves a tight arc through a lagoon. Its movement is quick but deliberate, the dorsal fin slicing the surface only briefly before disappearing into the mosaic of coral outcrops. Here, the shark is a sprinter, built for sudden acceleration and tight maneuvering. Schools of baitfish scatter at its approach, but the shark doesn't waste energy on them. It moves with the calm of an animal that knows the reef will offer something more careless. A parrotfish distracted while feeding, a moray eel that's drifted too far from its hole. Those are the moments it waits for. When the strike does come, it's usually over in seconds. Not far away, in slightly deeper water, another silhouette circles with more caution. The tiger shark. Broader, slower, and more deliberate, it relies less on speed and more on ambush and sheer presence. Unlike its reef-dwelling cousins, it doesn't hesitate to investigate almost anything that moves, or doesn't. Sea turtles, rays, sea snakes, and even floating garbage have turned up in its stomach. Its reputation as a scavenger is not unfounded, but its hunting behavior is far more nuanced. It uses stealth, often approaching from below or behind, banking on the prey's tunnel vision and relaxed defenses. Its jaws, lined with serrated teeth like a row of can openers, are designed to shear through bone and shell, not just flesh. Then, out in the open blue, well beyond the continental shelf, a different kind of predator reigns. The short-fin mako, one of the fastest fish in the world, operates not in ambush but in pursuit. It hunts high-speed prey, tuna, swordfish, even smaller sharks, using a unique combination of endothermy and streamlining. Unlike most fish, makos can regulate their body temperature, keeping their muscles warm and their reaction times high, even in cooler waters. Their torpedo-like shape reduces drag, and their long blade-like teeth are exposed even when their mouths are closed. A failed strike doesn't deter them. They circle, reposition, and go again, burning energy most sharks would never afford to spend. And then there is the great white. Massive, wide-ranging, and seemingly omnipresent along coastlines rich with marine mammals, it combines all three strategies: ambush, pursuit, and scavenging. Near the kelp forests of California, or the seal islands of South Africa, white sharks employ a vertical strike method that has become their signature. From deep below, they detect a seal's silhouette above against the sunlit surface, then accelerate vertically in a burst exceeding 40 kilometers per hour. In some attacks, the impact is so forceful that the shark breaches entirely, launching several hundred kilograms of muscle and teeth into the air. When successful, the seal is incapacitated immediately, but often it isn't. Failed hunts are more common than most assume. Seals are not helpless. They twist mid-air, spin underwater, and use the confusion of whitewater to dodge the fatal bite. Some have learned to stay close to shore or kelp forests, where the shark's bulk becomes a disadvantage. Others, particularly juveniles, remain in groups, relying on vigilance and numbers to minimize risk. Sharks, for all their power, do not win every encounter. Their efficiency lies not in perfection, but in persistence. A single meal can sustain them for weeks. They can afford to wait. Their senses, however, rarely wait for anything. The shark's advantage begins long before the attack. Specialized sensory organs allow it to detect electrical impulses in the water, the faint heartbeat of a fish, the twitch of a mussel. Rows of ampullae of Lorenzini, clustered around the snout, translate these signals into a map of vulnerability. Paired with a lateral line that senses vibration and a sense of smell that can detect a drop of blood in an Olympic-sized pool, the shark becomes a mobile detection system, one that tracks weakness, not just movement. But not all sharks are apex hunters. Some species, like the hammerhead, have evolved to specialize in prey others ignore. Their wide, flattened heads, called cephalofoils, are not for appearance but function. They allow for enhanced sensory coverage and maneuverability, helping the shark pin stingrays to the seafloor with pinpoint accuracy. Others, like the thresher shark, wield their elongated tails as weapons, stunning fish with whip-like strikes before circling back to consume the dazed. Even the Greenland shark, sluggish and nearly blind, survives in the freezing depths of the Arctic by feeding on carrion and, surprisingly, outliving almost every other vertebrate, some individuals estimated to be over 400 years old. Each species writes its own version of predation, tailored to its environment, its physiology, and its ecological role. The myth of the mindless killer, reinforced by decades of cultural caricature, does not hold up under observation. Sharks display curiosity, caution, and in some species, even social behavior. Scalloped hammerheads gather in large schools near seamounts, navigating together through magnetic cues and seasonal currents. Reef sharks establish territorial hierarchies and display tolerance or aggression depending on the social structure of the group. In the open arena of the sea, dominance is not simply about size or speed. It is about specialization. It's about knowing when to sprint, when to ambush, when to wait. It's about sensing the invisible, a vibration here, a current shift there, and acting at the precise moment when probability leans in your favor. For the shark, evolution has sculpted an animal that is neither monstrous nor miraculous, but necessary. It is the regulator of the ecosystem, culling the weak, keeping populations balanced, and maintaining the integrity of food chains that begin in plankton and end in teeth. As the sun falls and the water darkens from cobalt to indigo, the outlines of the hunters fade. The reef settles into its nocturnal rhythm. The open ocean slows its pulse, but the predators never sleep. Somewhere a fin breaks the surface, not in triumph or terror, but in function. The cycle continues. The law of the fin is not about violence. It is about control, earned, imposed, and understood. In a sea with no walls and no mercy, the shark does not rule by chance. It rules by design. Along the rocky coastline of a remote island, where the tide tugs rhythmically at the stones and the shoreline smells of salt and rot, the battle begins long before the waves arrive. Beneath slick boulders and across coral rubble, in crevices too small for fish and too obscure for predators, armored forms shuffle with deliberate intent. Crabs, ancient, armored, and opportunistic, rule this fractured domain not with speed or elegance, but with claws. Lots of them. They are not the ocean's fastest predators, nor its largest, but they are among its most ruthless. And in the jagged, competitive chaos of the intertidal zone, ruthlessness is the only currency that matters. From above, a crab's motion seems mechanical. Stiff-legged scuttles sideways, as if the creature were wound up on springs. But watch closely and there's more to the movement. Each step is calibrated, each shift in posture measured. Crabs rarely expose more of themselves than necessary. Their flat, rounded carapaces hug the contours of the rock. Their stalked eyes twitch independently, scanning for movement from every angle. Beneath the shell lies a body designed for both offense and defense. One claw, often larger than the other, one side built to crush, the other to slice. Take, for example, the fiddler crab, common in mudflats and mangrove roots. Males wield a comically oversized claw, not useful for feeding, but indispensable for fighting and courtship. They wave it in the air to attract mates or to warn rivals, a display of bravado as much as weaponry. When challenges arise, the claws clash in short, violent bouts. The winner keeps the territory. The loser often keeps the claw, only to lose it later in another fight. Regeneration is possible, but slow. Until it returns, the crab is vulnerable. In a world where nearly everything with legs is a potential threat, vulnerability is a dangerous luxury. Further out on the reef flat, as the tide retreats and the sun beats down on the exposed coral heads, another drama unfolds. Hermit crabs, soft-bodied scavengers wrapped in borrowed armor, begin the slow search for new housing. They don't build shells, they steal them or inherit them. Growth demands larger real estate, and suitable vacancies are rare. When a new shell appears, multiple crabs gather and size each other up, sometimes forming chains, each one hoping to upgrade. But the wait isn't always patient. If a crab wants a shell already occupied, it may attempt to evict the current resident by force, gripping and shaking, trying to dislodge its rival like a burglar prying at a locked door. Success is rare, but transformative. The loser may find itself naked and exposed, suddenly at the mercy of sun, birds, and predators. Cannibalism is not uncommon. In high-density areas or during molting, when a crab sheds its exoskeleton and its body is temporarily soft, others of its kind can turn hostile. A vulnerable crab is a convenient meal, especially if food is scarce. Crabs show no hesitation in turning on each other when the opportunity presents itself. Even juveniles must be wary, not just of predators from other species, but of their own kin. This brutal pragmatism reaches its extreme in species like the coconut crab. The largest terrestrial arthropod alive today, it can exceed 4 kilograms in weight and stretch over a meter across when fully extended. Found on islands across the Indo-Pacific, coconut crabs are slow, methodical omnivores. Despite their name, they do more than just crack coconuts. They hunt birds, steal eggs, raid other animals' burrows, and have even been documented scavenging large carrion. Their claws exert forces comparable to a lion's bite. Climbing trees at night with silent ease, they descend to rip apart fruit, carcasses, or anything they can overpower. Nothing is off limits. And yet, not all crabs are brutal for the sake of it. Some have evolved more peculiar strategies, proof that survival doesn't always belong to the strongest, but sometimes to the strangest. Boxer crabs, or pom-pom crabs, are a perfect example. Tiny and delicate by crab standards, they carry living anemones in their claws, waving them like weapons. These anemones, armed with stinging cells, offer a defense mechanism that deters fish and other small predators. In return, the anemones are fed scraps from the crab's meals, a mutualistic alliance forged not from muscle, but from manipulation. Still others employ deception. The decorator crab, for instance, takes fragments of algae, sponge, or coral and affixes them to its shell, becoming an extension of the seafloor. Camouflage is not an afterthought. It's a construction project, ongoing and adaptive. These crabs are walking collages, changing their disguise depending on habitat and threat. It's not that they avoid combat entirely, but they hedge their bets by staying hidden first. Crabs, in their staggering diversity, occupy nearly every marine habitat on Earth, from deep-sea hydrothermal vents, where vent crabs feast on sulfur-eating bacteria, to the high intertidal zones where ghost crabs sprint across beaches at twilight, vanishing into burrows like smoke into cracks. Some species thrive in fresh water, others in brackish estuaries, and a few, like the aforementioned coconut crab, have abandoned the sea entirely as adults. But regardless of environment, a few rules remain constant. If there is a fight to be had, crabs will have it. If there is food to take, they will take it. And if something gets in the way, they will go through it, around it, or under it. Their success lies in modularity. The exoskeleton is not just a shell, it's a chassis. Every segment of their body is purpose-built for balance, grip, defense, or combat. The pincers are multifunctional, tools, weapons, and utensils in one. Their eyes are compound, their antennae sensitive, their legs adapted for sideways scuttling and precise navigation through tight terrain. They molt to grow, and in doing so, risk death, leaving behind a ghostly copy of themselves as they harden once again. But each molting is also a reset, a chance to regenerate lost limbs, to expand territory, to assert new dominance. As the tide returns and the reef begins to vanish beneath foam and current, the battlefield resets. The scars of combat remain, shattered shells, dislodged carapaces, missing legs. But the combatants retreat, melt away into cracks and shadows. for now. Because as soon as the sun dips and the water cools, they will emerge again, ready to fight, feed, steal, and survive. In the open sea, speed and size often define the top predators. But on the seafloor, in the margins and trenches of the world's oceans, crabs rule through a different law, the law of resilience, of claws sharpened by conflict, and of survival that never takes a day off. In this arena, there is no single victor, only those still moving. The ocean never stops moving. Even in its quietest corners, beneath the still surface of a tropical atoll, or deep in the sunless trenches where life seems frozen in place, currents churn, unseen forces shape migration paths, nutrient flows, and boundaries of survival. Beneath the surface lies an interconnected kingdom, a biological machine fine-tuned over hundreds of millions of years. Each predator, each scavenger, each elusive drifter has a role, shaped not by dominance alone, but by adaptation, resilience, and a delicate, unspoken balance. From the open ocean to the tidal shallows, every creature must live by the rules written in water. The dolphin's cooperative ambushes are only effective because fish school in predictable patterns. The manta ray's wide-mouth filter feeding succeeds because plankton rises with the upwellings. The moray eel's cave strikes are timed to prey that use the reef for shelter. Nothing happens in isolation. Even the shark, long painted as the unchallenged apex predator, must maneuver around the habits of seals, the defensive strategies of turtles, or the speed of escapees like squid and tuna. For every technique of dominance, there exists an answer in retreat, evasion, or evolution. In this intricate web, success is measured not in brute victories, but in contribution to equilibrium. Crabs clean the detritus of the reef. Octopuses cull slow or injured prey, sparking turnover in the ecosystem. Seals transport nutrients between land and sea, while whales, through their exhalations and vertical migrations, help circulate iron and nitrogen, essential nutrients for phytoplankton, the base of the marine food chain. Even death contributes. When a giant dies, be it shark, whale, or sea turtle, its body feeds entire communities in the abyss. Scavengers, microbes, and organisms that might not see another feast for months. Yet despite this harmony, the ocean is no utopia. Competition is constant. Tensions rise and fall with breeding seasons, migrations, and moon phases. An octopus outsmarts a reef fish today, only to fall prey to a barracuda tomorrow. A dolphin may feast alongside its pod for days, then go hungry when tides shift. Adaptation isn't just a response to other animals, it's a response to the ocean itself. Currents alter coastlines. Temperatures fluctuate with El Niño events. Coral reefs bleach and recover, reshaping the geography of entire food webs. And still the system absorbs these shocks. Slowly, over time, species adjust. The balance flexes but rarely breaks. That is, until now. In recent decades, the rhythm of the sea has been disrupted, not by nature, but by us. Coral reefs, once vivid strongholds of biodiversity, now bleach with alarming frequency as ocean temperatures climb just a few degrees beyond tolerance. These reefs, which occupy less than 1% of the ocean floor, but support over 25% of all marine species, are crumbling. As they die, so too do the species that rely on them for shelter, feeding grounds, or breeding sites, from clownfish to crustaceans, moray eels to reef sharks. Without the structural complexity of coral, predator-prey dynamics begin to collapse. Some species vanish. Others, like jellyfish, surge in their absence, disrupting fisheries, clogging cooling systems, and further unbalancing already fragile ecosystems. Pollution seeps into every current. Microplastics, now found in the digestive systems of everything from filter-feeding whales to crabs on the sea floor, alter feeding patterns and compromise health. Oil spills and chemical runoffs destroy coastal nurseries where young fish, turtles, and cephalopods once flourished. Sound pollution from shipping lanes and sonar disrupts migration and communication, particularly for marine mammals who rely on echolocation for navigation and hunting. Climate change alters not only temperature, but chemistry. The ocean, in absorbing a quarter of the carbon dioxide released into the atmosphere, has grown more acidic. Shell-building animals, corals, mollusks, planktonic foraminifera, struggle to maintain their protective structures. As these foundational species decline, so too do the predators that depend on them. The collapse is quiet at first, slow and piecemeal, but it spreads, undermining the system from the bottom up. And yet, amid these crises, there are glimmers of resilience. Some species of coral have shown increased tolerance to warmer waters. Certain populations of reef fish are adapting to degraded habitats by changing feeding behaviors or altering reproductive timing. Marine protected areas, though still limited, have proven to allow ecosystem space to recover. In zones where fishing has ceased and pollution is reduced, biomass increases, predator numbers rebound, and natural interactions slowly re-establish. The ocean, given even the slightest reprieve, begins to heal itself. But time is a factor. Evolution is slow. Human change is fast. For every reef that begins to recover, there are dozens still dying. For every coastal zone where sea turtles hatch safely under protection, others vanish under the weight of beachfront development and artificial lighting. The balance that once defined the ocean has begun to tilt, and its future may no longer be dictated by predator or prey, but by policy, preservation, and the choices made above the surface. In the silence beneath the waves, nothing seems to change. Sharks still patrol, dolphins still echo, crabs still duel over shells. But the foundation has shifted. The currents that once carried nutrients now bring warmth and waste. The patterns that once ensured survival have become uncertain. The Blue Kingdom remains vast, powerful, and filled with life, but it is not invincible. To understand the ocean's predators is to understand the systems they serve. None exist in isolation. The shark that hunts at the edge of the reef is connected to the plankton bloom that feeds the fish, that feed the squid, that feed the seal that flees into the kelp. The reef that shelters the moray depends on clear water, regulated temperatures, and unbroken cycles. The manta ray's path through open water depends on unseen eddies, phytoplankton clouds, and the protection of breeding sanctuaries. In this final current, everything converges. The ancient strategies of survival, the daily calculations of hunter and hunted, the silent collapse of coral kingdoms, the rising urgency of change. The ocean does not need us to save it. It needs us to stop tipping the balance. Because in its vastness, it has always known how to regulate itself. It has always held its own order, shaped not by dominance but by interdependence, a law written not in blood or bone, but in motion. And that law remains even now hidden beneath the waves, patient, intricate, and still alive.